Hey guys, our I can statement for math today is I can solve two-step word problems, that's right, two-step word problems again, and see if they are reasonable. Okay, let's go for it. Quinn wanted to say hi really quick. He likes to see himself in the camera. Alright guys, let's do it. Okay, so our first problem is, and sorry, my face is going to be kind of cut off because I just can't make it work. Anyway, there were 9 rows of chairs set up in the school gym. Each row had 20 chairs. After the students were seated, there were 12 empty chairs. How many chairs were filled? Okay, so again, two-step word problems have a lot of words, a lot of numbers. Don't let that scare you. Draw it out, understand what's happening. So, I know that there are 9 rows of chairs, and in each row, there are 20. So I'm going to draw that, 9 rows with 20 chairs. So drawing 9 rows and 20 chairs in each row would have been crazy, so I did 9 groups of 20, because that's the same thing, right? Alright, so now I see how many chairs there actually are. There's 9 times 20 chairs. That is my first step. I could even write that down. The first thing I did was draw 9 groups of 20, so my first step to this problem is 9 times 20. Perfect. Now, I don't know what 9 times 20 is, but I know my 10 trick, right? So I know that I can take 9 times 2, which I know is 18. 2 groups of 9 is 18. And I can say, oh wait, hey, I'm a 10. Gotta add that 0, so I know my answer is 180. Perfect. So now I know there's 180 chairs in all. The second step in here is, after the students were seated, there were 12 empty chairs. So 12 of these chairs have no one sitting in them. And I want to know how many chairs are full, so I have to take off those 12 empty chairs, right? Because no one's in them, so that's not part of my answer. So I'm going to cross off those 12 chairs. I can just go to this circle right here and say, okay, well, let me take off 12. Here's 10, I'll take off 10. And then out of this, I will take off 2. So what's left is 3. And to make that easier for me to see, I can erase that and put 3 tallies because that's easier for me to tell what I did. Okay, now I know what my second step was. And I'm going to erase this right here so that I can write my second step. My second step was I took 180, so step 2. I took 180 chairs, right? And I subtracted those 12 empty ones. And 180 minus 12 is just 100, and then 80 minus 12, which is 68. So my answer is 168 chairs are full. Now, I'm going to show you how to put these two equations together, okay? So I'm going to erase my drawings, keep these equations up, and show you how to push them together. So here are my two equations, 9 times 20 and 180 minus 12. Because 9 times 20 is 180, and we start our next equation with 180, when we write our new equation, we can just take that out because they're both right here. So they kind of cancel out. Do you see that? Because they're both in each equation, I can cancel them out. So it's like, oh, well that's here and it's here. So it's not there at all. When you get older, you'll use the word canceling out a lot, and it just means if something is happening on both sides of an equation, then you don't need it. So since this is happening on both equations, we don't need it. So instead we can say 9 times 20, and then what is the thing we didn't cancel out in that second equation? This minus 12. So we can do minus 12, oops, sorry. And then the other thing we didn't cancel out is this equals 168. Equals 168. Now, because we know PEMDAS, we know that we actually don't need any parentheses because we want multiplication to start first, and it already will. And then we want to subtract the 12. However, if it's easier for you to see what's going on and you want to separate what is happening, you can add parentheses. For example, if I want to know that this is that first equation, and then I take the answer from that first equation and subtract 12, I can add parentheses just to make it easier for me. But that's how you put two equations together. If something cancels out, take it off on both equations, right? And then you get the answer in one equation instead of writing two. It's great. Okay, let's do one more of these, and then we'll do one is it reasonable problem, then we're done for math, okay? Okay, our second problem, let's go. Brandy had 8 equal rows of stickers. She bought 5 more stickers, and now she has 53. How many were in each row before she bought more? This one is a little tricky because I don't know how many things are in my rows. But don't let that trick you. Draw your picture, understand what's happening. So the first thing I did in my picture was draw 8 groups. Now I didn't draw how many things were in the groups because I didn't know. So you're going to show that in your equation. Your first step was 8 groups of some amount of stickers, but you don't know how much. So S for stickers equals, and again, you don't know how many stickers there are, so you don't know what that equals. Question mark. Let's do our next step. Our next step was just down here. I'm adding 5 stickers onto all the stickers I had in these groups. So put that as your next equation. I took this amount, I don't know how much it is, and then I added 5 onto that. And that equals, after I've added those 5, equals 53. So my total answer is 53. Now let's push those equations together, okay? To do that, remember, take off that thing that is in both equations. S is not in both equations. Oh, and sorry, this is an S, not a 5. That's a little confusing. I don't see 8 in both equations, and I don't see 5 in both equations, so the only thing is the question mark. So I'm going to take off the question mark in both of my equations, and then just smush them together. So I have 8 times S, 8 times S, plus 5, because I didn't cross that out, equals 53. Now that we've smushed them together, let's solve. I'm going to erase, and then we'll solve this together, okay? So in order to solve this, you need to use some critical thinking. That means you need to look at this and think about what it is telling you. What do you know that's going to help you figure out the answer? I know that 8 times S plus 5 has to equal 53. So this equation right here has to equal something that adds to 5 to equal 53. So that was a lot of words there. I hope it made sense. So what I'm going to do is take 5 away from 53 to figure out what this needs to equal. Let's do that. Remember to stack up your numbers when you subtract. So 53 minus 5. Oh, if I only have 3 things, I can't take 5 away from it, right? There's not enough. So I got to go over to my tens and steal some. Sorry, 5, you're now 40. But good 3, you're now 13. And 13 minus 5 is, well, count up from your fingers. That's what I always like to do. Or count down. So 13, 12, 11, 10, 9, 8. Okay, 13 minus 5 is 8. And then 40 minus nothing, still 40. So 48. That means 8 times S has to equal 48. So I can turn this whole thing into division, put that in green at the bottom. I need 48 divided by 8, and that will tell me what S is. And do we know what 48 divided by 8 is? It's 6. So now I know that S equals 6. So I know that before she bought more, there were 6 stickers in each row. That was a long problem. It was difficult, but we got through it. We used critical thinking, and we did it. Good job, guys. The last thing to talk about is those is it reasonable problems. I'm not going to make us do another 2-step and solve it all out. We're just going to talk about it. So For example, if the problem gave you their answer was 150, and you had to figure out if that was a reasonable answer, you would solve the problem. And if you got 196, would that be reasonable? Would their answer be reasonable? Probably not, because 196 is nowhere near 150. 196 doesn't even round to anything close to 150. 196 would round to 200, right? So those aren't close. These are not reasonable. Let's look at 20. Now, if they said their answer was 20 and they were asking, is that a reasonable answer? And you got 17, would that be reasonable? Are those numbers pretty close together? Yes, for one thing, they're within 5 numbers of each other, so that's great. That's a pretty reasonable answer. Also, 17 rounds to 20. So if I used rounding, this would also work. It's reasonable. So I would say yes. Lastly, if they told me they got 33 and I got 35, would I say that's a pretty reasonable answer? Absolutely. 35 is only 2 numbers away from 33. So I'm going to say yes, that's reasonable. If you were just guessing and you told me about 33 and the real answer was 35, I'd say that's a pretty dang good guess, right? All right, so that was today. We learned about two-step word problems again, and we learned, is it reasonable? You guys are doing great. If you need any help, you can always rewatch the video and skip to the part that you need help at, okay? Have a great day. You are somebody. You were somebody when you came. You'll be a better somebody when you leave. I love you all. Have a great one.